All right, everybody, welcome. We're looking at 3.4, which is dividing fractions. So here we have a few examples. And the first example here is 2/5 divided by 3/4. And so here we can keep the first fraction the same. We can change the division sign to a multiplication sign. And then finally, we can flip our second fraction of 3/4 and make it 4/3. So when we multiply by the reciprocal, or simply keep, change, flip, it's going to give us the same answer, 8/15. All right, so 2/5 divided by 3/4 gives us 8/15. So let's go ahead and utilize this keep, change, flip method. We have 1/2 divided by 1/3. So again, we're going to keep that 1/2 the same. We're going to change this division sign to a multiplication sign, and then we're going to flip this 1/3 to 3/1. And if we multiply across the top, 1 times 3 gives us 3. Multiply across the bottom, 2 times 1 gives us 2. So here we have 3/2. And if you wanted to, you could write this as a mixed number, 1 and 1/2. And since we don't have any negative factors in this problem, we know our answer is going to be positive. So let's go ahead and take a look at the next problem. This one we'll do in purple. And so right away I noticed I have one negative factor. And so my answer is going to be negative. And now I'm going to use that method of keep, change, flip. So I'm going to keep that first fraction the same, -1/2. I'm going to change my division sign to a multiplication sign. And then finally, I'm going to flip that 3/5 and make it 5/3, multiplying by the reciprocal, we call it. And here we're going to get 1 times 5 on top. And we're going to get 2 times 3 on the bottom. So we have 5/6. And now let's think about it. Can we reduce this? Is there any number that goes into both 5 and 6? No, there isn't, other than 1. So that would be our final answer. All right, so I think we got the method down, keep, change, flip. So let's go ahead and go through the exit ticket together. First thing I'm going to do before I even do these problems is I'm going to circle all of my negative factors. And so in my first problem, I have 0 negative factors. So my answer is going to be positive. In my second equation here, we have 1 negative factor, so my answer is going to be negative. We have 2 negative factors in our third equation, so my answer is going to be positive. And finally, in our fourth and final equation, we have 1 negative factor, so my answer is going to be negative. All right, we got that out of the way. Now we can focus on the keep, change, flip. So let's keep that 2/4 the same. Let's change that division sign to multiplication. And let's flip that 5/3 and make it 3/5. So here we're going to keep that as 2/4. Multiply across the top. 2 times 3 gives us 6. Multiply across the bottom. 4 times 5 gives us 20. All right. Is there a number that goes into both 6 and 20? Let's see. They're both even numbers. So that means that they're both divisible by 2 at least. Let's divide 6 by 2, and let's divide 20 by 2. That's going to give us our new equivalent fraction of 3/10. Is that in the simplest form? Let's see, is there something that goes into both 3 and 10 other than 1? Don't think so. So that would be my final answer, 3/10. Now we can look at the next problem. We're going to keep, change, flip, KCF. So it's going to stay -3/6. Division turns multiplication. And then finally that 2/10 will turn to 10/2. And now here is a method that we can do before we multiply. And it's called simplifying before multiplying. And so what I'm going to do is take a look and see if there's any numbers on top that can be divided by some of the numbers on the bottom. All right, so what I mean here is there like a number that goes into both 10 and 2? So we could simplify the fraction before we multiply. Yeah, we could change this into 5/1. And now our problem reads 3/6 multiplied by 5/1, which is a lot easier than multiplying by 10/2. So 3 times 5 on top gives us 15. 6 times 1 on the bottom gives us 6. So we have 15/6. And wait a second. Isn't there a number that goes into both 15 and 6 here too? 3. So if I divide both by 3, then I'm going to have 5 over 2. And now I'm in the simplest form. And now since it's negative, it's going to be 5 over 2, but it's negative 5 halves. All right, same thing for problems 3 and 4. Keep change flip. That's going to get you your answer. Don't want to be too repetitive here. And now we're going to look at the word problem here, question 5. These are always the toughest, right? Because it's not just a simple rule we follow. We actually have to figure out how we set up the equation too. All right, first things first, I want to figure out what numbers I'm working with here. A relay race covers 5 halves of a mile, or 5 over 2 miles. So that's what I'm going to start with. Each runner on a team is going to run 1/4 of a mile. How many runners are needed for a team? All right, so imagine we had a track that was exactly 1 mile long. So I'm going to go ahead and draw it here. This is my mile-long track. And if you were to run 5 halves of a mile, well, you go around once, so that'd be 2 over 2. And then you go around again, and so now that would be 4 over 2. And then you still have to go one more half to get 5 over 2. All right, so here I'm going to go around half the time. And we have runners on the team that are going to run 1/4 of the miles each. So let's go ahead and do that in purple. All right, each runner is going to be running 1/4. So that'd be 1/4 here, 1/4 there, 1/4 there, 1/4 there. So it'd take 4 runners to run a full mile. All right, so let's use keep change flip to see how many runners it would take if we ran 5 halves of a mile, or 5 1/2 miles. Keep it, change it, flip it. Scroll down here a bit. 5 halves are going to stay the same. That division sign is going to change to multiplication. And then finally, we're going to flip that 1/4 and make it 4 over 1. See if we can simplify before we multiply. Is there a number that goes into both 4 and 2? Yeah, we can make them both divisible by 2. So we have 2 on top, 1 on the bottom here. Now we have 5 times 2 on top. Gives me 10. And then we have 1 times 1 on the bottom gives me 1. 10 divided by 1 equals 10. So we have 10 runners in order to run 5 over 2 miles. All right, nice job on exit ticket 3.4. Please let me know if you have any questions. We're going to move on to 3.5 in the next video. Thank you.